So you may be saying to yourself, all that stuff in the first couple of videos seemed pretty easy. Well, what happens when we complicate things just a little bit? Well, the thing to remember is that if we have expressions that are added or subtracted, we're looking to see if there are any common terms that we can add. And common terms mean that we have variables that are raised to exactly the same power. Well, it looks like maybe there might be some chance of that happening here, but we won't know until we actually carry out the multiplication. So in fact, in this first expression, we're going to have to carry out the multiplication for these two terms and then find out whether or not we've got any like terms. So let's try it out right here. In the first case, 3a squared b squared times the quantity 2ab. Well, the first thing I'm going to do for this term is I'm going to drop my parentheses so I can do all the math, and that means I'm going to take 3 times a squared times b squared, multiply that by 2 times a times b. Now I'm going to multiply my constants, 3 times 2 to give me 6. I'm going to take a squared times a, multiply b squared times b. Now, if we are multiplying a squared times a, it might help to remember that if we said a, it's the same thing as a to the first, and b is the same thing as b to the first. So our very first term is going to become 6a to the third power times b to the third power. Now let's take a look at our second term. We're going to do the same thing. We're going to get rid of the parentheses right here. There's no powers on the outside of them, so we can do that. We're going to get 9 times a times b squared times a squared times b. And if we put our like factors together here, our like bases, a times a squared and b squared times b, remembering that a is the same thing as a to the first and b is the same thing as b to the first, we're going to get 9 a to the third times b to the third. And yeah, now it does look like we do have like terms, and if we add like terms by adding their coefficients. This is really almost the same thing as saying 6 minus 9 times a cubed times b cubed. And if we treat it that way, we know that we end up with negative 3 a to the third times b to the third as our result. Well, let's take a look at this next example right here. This one looks like way complicated. Well, it is and it isn't. It's the same sort of idea that we were just talking about in our last example. The only real goal right here for us is that we've got two terms, and we want to get rid of the parentheses and then simplify each part of the expression so that maybe we'll be able to add together our like terms. So let's try that out. For negative 2 times x times y, there are no common bases that we can multiply. But we do want to bring x squared times y raised to the third out of the parentheses. And to do that, we have to distribute our exponents. So this is going to become x squared to the third times y to the third. In our second term, we can do a very similar thing right here, and we'll do that in just a minute. But let's simplify here completely. We're going to have negative 2 times x times y times, let's see, x to the second to the third means that we multiply our two exponents. Remember that rule. So that becomes x to the sixth times y to the third. And if I take my like bases together, x to the first and y to the first, I will get something that should look a little bit like this: negative 2 times x to the seventh and y to the fourth. Now I move over to my second term right here. I've got 3x to the fifth, and I can just leave that out of a parentheses, but to get rid of these parentheses, I need to make sure that each factor inside of the parenthesis is raised to the second power. So I'm going to get times x to the second power and y to the second power raised to the second power. This is a very similar arrangement to what we had on the left over here. So if we carry this out, we've got 3x to the fifth, x to the second, times y to the 2 times 2 fourth power, So if we simplify that one more time, we've got 3 times x to the 7th times y to the 4th, and we do have two like terms. And the way we combine these like terms is to combine their coefficients. So we're going to take -2 minus 3 times x to the 7th y to the 4th, and our result should be -5 x to the 7th y to the 4th. The rest of your assignment is surprisingly similar to these problems. Good luck, and I'll see you in class.